Hello students, Ms. Slyman here with your 4.4 notes. These are Introduction to Logs. I'll get to this in a second. So the first thing we want to do is think about an exponential function. So if I'm going to write it as f of x, that's me really showing that it's a function of x. If I'm going to use y, it also is dependent on x, so it doesn't matter which one I use in this case, but I should only use one. So if I'm thinking about the function of x, I'm going to write that as f of x. So f of x equals 2 to the x. 2 to the negative 2 is 1/4. 2 to the half, negative 1 is a half. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 to the third is 8. Even though it says domain of negative 2 to 4, that doesn't actually fit. I'm going to try and draw my asymptote and then go through the curve. Hopefully your graph didn't actually go under the asymptote like mine did right there. All right, so here's my 2 to the x graph. And I could say y equals or f of x equals. So using this graph, I want to know when the graph is equal to 4. So my graph is equal to 4 when x is equal to 2. When is the graph equal to 8? The graph has a value of 8 when x is 3. When is the graph equal to 7? Well, that's about here. It looks like it's about 2.8 or 2. It's hard to see on this small of graph. I'm going to go over to Desmos. I've already put in y equals 2 to the x. So 7 is here. Comes down. Maybe it looks like it's about 2.75 or so. And of course, I could use my technology, either your calculator or on Desmos, and we could put in y equals 7 and then look and see where they intersect. So 2.8. But if we're using our graph here, whatever's close on your graph, 1/4, that was a point we saw over here. That happens when x is negative 2. The value is equal to 1 when x is 0. And it's equal to negative 1, never. So this has no solution. So these 4 are easy for us to solve because 4 is the same as 2 to the power 2. 8 is the same as 2 to the power 3. 1 is 2 to the power 0. So I could set up an equation. But this one, if I wanted to use my calculator and just calculate it to solve it, if I wanted to use algebra and not the graph, well, I need an opposite operation. When I have multiplication, and that's what I had written before, if I have 4x equals 27, let's say, if I wanted to find x using algebra, I would divide both sides by 4 because that's the opposite operation. Well, we need an opposite operation for exponents, and that's what a logarithm is. So if I'm thinking of this as the function form, so f of x, then the inverse function, I call it f inverse of x, is log base 2 of x. So here, I want to know what is the exponent. The log gives the answer. So if I have this written down, it's basically saying 2 to what power, that's the answer, is x. If I think about the inverse, the domain and range, so all of my answers here could have been positive or negative for the exponents. So the range, the y values that I get out, could be positive or negative. Or they could be decimals. So y can be any real number. This is the answer to the power. When you take 2 and raise it to a power, you're always going to get a positive number, never a negative. So the domain in this case for the log function is that x is greater than 0. Our base power also has to be a positive. Now, if I want to think about just switching these things around, currently this y is the answer to the evaluated power. So in this case, if we go back to our example of 2 to the x equals 7, in this case, the y value is 7, the a value is 2, and the x value is x. If I use the inverse to rearrange this, I would say log base, so if I used logs to rearrange this one, sorry, I would say log base 2 of 7 is x, because I'm asking 2 to what power is 7? 2 to what power is 7? So switching this one around, log base a of y, because that's the final answer, is the exponent. So the answer to a log gives us an exponent. That's why it can be any real number. Positive, negative, fractions, doesn't matter. Any real number. The input, though, has to be positive. So anytime I raise something to an exponent, I get a positive number. A, my base, like we explored in class today, the base has to be positive. So it's really a bit confusing to look at this in words. Let's go and look at some examples, and we'll do that in the next video.